Binomials by binomials. Okay? And I'll probably show you two methods. You'll probably hone in on one of them that you prefer and kind of do that. So yesterday we learned distribution, right? That's where we took the monomial, we distributed it, looked like a little rainbow going into the brackets. That still works for everything that you do. It's just the distribution might look a little more confusing. It might be hard to organize your work and make sure you do it all perfectly. So instead, I think most people prefer doing something called an area diagram to multiply binomials by binomials. Okay, the first question they filled out for you, they're multiplying x plus 3. They're multiplying x plus 3 times x plus 2. Okay, that's a binomial and a binomial. I know they're both binomials because the first set of brackets has a plus in the middle, right? So that's two terms, x and 3. The second binomial is x plus 2. There's a plus in the middle, so x and 2 are two separate terms. The way an area diagram works is you take each binomial and you break it into its parts, into its terms. So the first binomial, x would be the first part, I put x. 3 would be the second part, I put 3. Then I'm going to take the second binomial, break it into its parts, and write it down the side of a grid. So x plus 2. And you've made this like grid. And you'd have the inside empty. Obviously, they filled it in for you already. The inside part of the grid is what happens when you multiply the column by the row. Right? So if you look at this, I need a better color. So if you did x times x, it creates x squared. Right? You're going column by row to create the middle part. That means 3 times x becomes 3x, 2 times x becomes 2x, 3 times 2 becomes 6. Right? And you get 4 things when you multiply two binomials. Those 4 things are your answers. Okay, so if you look at that, these guys are your answers. That's what happens when you multiply. So we write it out into a nice long row. And I would write it out as x squared plus 3x plus 2x plus 6. The last thing you would do is look to see if there's any like terms. Remember, like terms means same letter, same exponent. So if you're looking, same letter, both of these are x, and same exponent, they both have exponent 1, they would combine to be 5 x's. Right? You just add the numbers. 3 plus 2 would be 5 x's. Your final answer to this thing would be x squared plus 5x plus 6. That's like a completed example for you. I don't think it ever really does a good job of explaining things, but at least it's there in case you missed today or something. Right? We're going to do a bunch together, and then you're going to get a lot of practice time today to work on your multiplication skills. All right. We have to multiply two binomials together. We look at this. I know this is two binomials. Right? The first binomial is 5x minus 6. That's two separate terms because of the minus sign. This is a binomial, 2x plus 1, separated with a plus sign. I know they're multiplying because the brackets have nothing between them. And that means multiply. We don't actually write multiplication symbols anymore. Awesome. To multiply those two things together, I'm going to do an area diagram. That means I'm going to take the first binomial and I'm going to break it up into its parts. So 5x minus 6. Then I'm going to take the second binomial and break it into its two parts, but down the side. You should end up with a grid like that. Okay? 2 things across the top, 2 things down the side. And 4 spots in the middle. The 4 spots in the middle are what you have to fill in. To do that, you multiply the column and the row. So if we're looking at this first blank, we have 5x times 2x. Numbers with numbers, letters with letters. 5 times 2 would be 10. X times x would be x squared. We add the exponents. We have 3 other spots we need to do this with. It's 2x times -6, numbers with numbers. 2 times -6 would be -12. The x has no other x's to multiply by, so it's just x. Next blank spot, we have 5x times 1, numbers with numbers. 5 times 1 is 5. X times no x's is x. Last one, -6 times 1 is -6. You should end up with the middle being completely filled out. That is your solution. Okay, so I would write all 4 things out in a row. That means that my answer would be 10x squared minus 12x plus 5x minus 6. X's are just always connected at the top. It's frustrating. If there's like terms after you multiply, you should collect them, right? So that means simplify them. If you look, these are like terms. They have the same letter, same exponent. So if I have -12 of something plus 5 of something, put that in your calculator, go -12 plus 5, and you should get -7 x's. The other things stay the same. So 10x squared is still 10x squared. And -6 is still -6. Your answer when you multiply those 2 binomials together would be 10x squared minus 7x minus 6. Beauty. Okay, let's do another one together. So we look at B. I have a binomial, so I break it up into its parts. A squared minus 5. And I'm creating a grid. The grid is called an area diagram. Down the side, I really like that color being though. Yeah. We have a squared minus 8. When you do your grid, your top left-hand corner, just for the record, this should be like empty. So sometimes people screw up their area diagram and they put it too high and then there's nothing there. Right? You should have nothing in this top left-hand corner. So I put a little smiley face. You can put whatever you want up there. If I was an artist, I'd do something better than that. But that's about as good as my art gets in here. In the middle, we are going to multiply columns by rows. A squared times a squared, I add the exponents. That becomes a to the power of 4. Right? Remember our skills from last unit. Then I have a squared times -5. That would be -5a squared. I have -8 times a squared. That becomes -8a squared. -5 times -8 becomes +4. When you're done, you should have the entire grid filled out. That is your solution. You just need to write it out and then collect like terms. When you write it out, you should end up with something like this. A to the power of 4 minus 5a squared minus 8a squared plus 40. Right, that's the 4 things in the middle all written out. There's usually like terms somewhere, typically in the middle. You'll notice these are both a squares. We're adding or subtracting them, so we only deal with the coefficients. So we have -5 minus 8. You go in your calculator, -5 minus 8. So you get -13a squared. Remember that the square doesn't change because we were adding or subtracting them. And we weren't multiplying. That's the only time the exponent changes. The other things will stay the same. So I have a to the power of 4 minus 13a squared plus 40. That's a 40, not a 90. Give C and D a try. Just try them on your own. No one can see your page. I'll put my answer up on the board and I'll go through it with you. But just try. See if you can do an area diagram. You got a binomial times a binomial, right? So the first one's going to go across the top. That means 3p, 2q. And you're building your grid. Then you have p and 9q. On the inside, when you multiply them together, 3p times p would be 3p squared. 2q times p. That might be a difficult one for us because what do I do with those different letters, right? So if you got stuck at that point, that's okay. That's kind of normal. When you have different letters, you can't do anything with them, so you just write them side by side. So 2p times q would become 2pq. If you had it 2qp, that's the same thing, right? We typically go alphabetical. I think p comes before q. But as long as you just have them both written up. That means this guy, 3p times 9q, the numbers of the numbers becomes 27. But then the p and the q can't do anything, so it just becomes pq. The last one, 2q times 9q is 18q squared. Okay. That's what your error diagram should look like. You should have those 4 terms. You then write out all 4 terms. When you write out all 4 terms, you get 3p squared plus 2pq plus 27pq plus 18 squared q squared. You should have a couple terms that are the same. You have 2pq and 27pq. Those are like terms because they're same letters, same exponent, right? They're both the power of 1, they're both p, they're both q. Those things combined become 29pq. Everything else stayed the same. So 3p squared, couldn't add with anything because it was different exponents. And plus 18q squared, couldn't add with anything because they're different exponents, right? And you have a q, but it's q to the power 2. How many people got that one? That was hard. Yeah? Good. Good job, guys. For D, you have all different letters. So if we look at that, we got A, B, make your grid, C, D, like that. I create the little tiny. That gives me A times C, C times B, A times D, and B times D. And you just end up getting all those paired up letters. So it's really a good rehearsal. And what do you do when you have 2 letters multiply each other that are different? You just write them beside each other. Preferably alphabetical. At that point, when you write them all out in a row, you're going to notice that you have no like terms. Hard to show it, but it's there. You have no like terms. The reason you have no like terms is you have to have all the same letters in a term with all the same exponents. This one has an A, this one has an A. But the second letter in each one is C and D, so they're different, right? B and B are the same, but C and D are different, so those aren't the same terms. These are 4 different distinct terms. Awesome. That's area diagram. Area diagram works for like every single question. So people typically like area diagram. It's organized, right? It's neat. It keeps all my work in order, which for some of us is really hard. And it's not that challenging. Right? As long as you can remember some of your fundamental math rules, it's not that crazy. There is another way to do these questions. We're going to skip past the using area diagrams on numbers because that's hogwash. And we're going to come down here to doing the distributive property on binomials times binomials. And we have polynomials together. They show it their way. I don't like their way. I don't know why. Maybe I just think I'm better than them. I don't know. But I'll show you my way. If you ever talk to your parents or an older person, and you don't got to be that old, you got to be like, I don't know, a generation above you guys, they probably have heard of something called FOIL. FOIL is the distributive property. It's the same thing. Okay, so I'm going to teach you both. But it really is the same thing. FOIL is just like a neat way of remembering to distribute. That's all it is. The way the distributive property works is when you look at this question, like x plus 3 times x plus 2, I could take the first term, which is x, and I could distribute it into the brackets on the other side. Right? So when I do that, that becomes x squared. X times x is x squared. X times 2 is plus 2x. Then I could take the next term in my brackets, which is a 3. And I could distribute it into the brackets beside it. So it becomes plus 3x plus 6. That's the exact same thing as doing area diagram. You end up with the same 4 terms, it's just a different way of looking at it, a different way of organizing it. Make sure that every term in your first set of brackets gets distributed to every term in the second set of brackets. That's what can make it kind of challenging, right? It gets a little messy in there. You should end up with like terms. I have a 2x and a 3x. Those be combined to become 5x. So my final answer would be x squared plus 5x plus 6. That. I'll show you a couple more. Then I'll let you try a couple. Okay? So if you're looking at that middle one, let's see, how'd it go? So this middle one, we're going to distribute it. So if you got that on a test, you could area diagram it. Okay? Like, see, you could make a grid out of those 2 different polynomials. We're going to show distribution. So you take your first term of the first binomial and you distribute it to the first term of that binomial. A times 2a becomes 2a squared. Then this a also has to get distributed to the last term out there. A times -1 is -1a. I've now taken the first term and distributed it to everything in the second bracket. I move on to the next term, which is a -7, and I start distributing it into the brackets on the other side. -7 times 2a is -14a. My last one, I'll take that purple. -7 times -1 becomes +7. I'm trying to do a little more rainbow so you can see where numbers are coming from. Right? I've distributed everything from the first brackets into everything in the second brackets. Again, you typically end up with like terms somewhere in the question. In our case, we did right in the middle. We have -a minus 14a would be -15a's. Everything else stayed the same. So 2a squared is still 2a squared, plus 7 is still plus 7. I find distributions a little faster, in my opinion. Area diagrams maybe a little more organized, a little more neat. Probably makes little mistakes with area diagram. We'll do C together. I'm going to let you try D and E on your own. So if you look at C, I have 2 binomials. I'm going to take the first binomial, take the first term of the first binomial, and distribute it in. That will become P cubed and then -8P. Then I'm going to take the next term, which is -8, and I'm going to distribute it into the second set of brackets. That will become -8 cubed and then +64. Again, you look to see if you have any like terms. In this case, we don't. The first term is a p cubed. There's no other p cubed. The second term is just a p. There's no other just p's. The third term is just a cube. There's no other ones with just a cube. And then the last one is a constant because it has no letter attached to it. So that is my solution. Awesome. Try the next two on your own. Okay, remember your exponent rules when you're multiplying things together. It's a little tricky, but give it a shot. See if you can do that last one on your own. Oh, no mistakes even better. So if you look at the first guy, we're going to distribute this in. X goes in to become x squared. X goes across to become negative 5xy. If you wrote it negative 5yx, it's the same thing. Okay. The next term would be 4y, goes into be plus 4xy. And then 4y goes across to become negative 20y squared. That 4y, xy looks crazy. It connected all over the place, huh? When you do that, that's the doing the proper multiplication. Now you need to simplify, which means collect like terms. We do have a set of like terms in here. We have negative 5xy's plus 4xy's. Right? I can add those coefficients together. Negative 5 plus 4 will become negative 1xy. The other numbers remain the same because they have no other like terms. That is your solution. Awesome. Last one. This one's a good one for remembering your exponent rules. So I multiply 9a squared by 5a cubed. 9 and 5, numbers with numbers, becomes 45. A squared times a to the power of 3. When I multiply letters with letters, I add the exponents to become a to the power of 5. Then I distribute across to the plus 6 to become plus 54. A squared, that's a 54. Then negative 1 becomes negative 5a cubed. And my last one becomes negative 6. That's my final answer. Because there's no like terms, because the exponents are all different. A to the power of 5 cannot be combined with a to the power of 2, cannot be combined with a to the power of 3. Right? They're all different exponents. Any questions about that? Why'd I get a number where I got a number? Alright. FOIL. I'm going to show you FOIL. The more and more I teach math, I feel like FOIL is very irrelevant. I think it's a cool little nickname somebody created for binomial times binomials, and people fell in love with it for some reason, like 50 years ago, and now they keep teaching it. Like, it really isn't that great of a method. The reason it's not that great of a method is it only works for binomials times binomials. Okay? That's the important precursor to FOIL. It only works with binomials times binomials. The other methods we've learned, area diagram and distribution, they work for any type of polynomial times polynomial scenario, which is much more useful to us, right? This is very much like a one tool for one situation. The other two things can be used across the board, which is why I like them so much. FOIL is a fancy way of saying distribution. And what it says is, well, I think it's actually just like right above us. What I was just looking right up. Yeah. FOIL is an acronym. Okay? It stands for how you need to multiply your two binomials together. The F stands for multiply the first term in each binomial together. So in the first question, F would be x times x to become x squared. And that's what the F stands for, the first in each bracket. The O in FOIL stands for the outside terms, meaning if you looked at these binomials as like a sandwich, like the outside terms would be here and here, right? They're on the outside. So the O in FOIL would be x times 4 would be 4x. The I in FOIL stands for inside terms. That means, again, if you're looking at it as a sandwich, those are the two middle terms right here, inside of the sandwich. 6 times x becomes 6x. And L, which is the one that I like the least, stands for the last term in each binomial. So if you look at the first binomial, the last term is 6. Second binomial, the last term is 4. 6 times 4 would give you 24. And you end up with the same four terms like we have in every other method. It's just a different way of getting to those four terms. Again, you can collect like terms. So x squared can't combine with anything. 4x plus 6x would be plus 10x. And then plus 20. If you're getting help from your parents, that's a 24, not a 29. I'm so frustrated. Anyways, if you're getting help from your parents, there's a good chance they've heard of or know FOIL. And it's been around forever, and for whatever reason, it just like keeps sticking around. In reality, it's just distribution, right? First term gets distributed in, outside term gets distributed in, inside term gets distributed in, and the last term gets distributed in. It's the same thing, just a fancy way of saying distribution. I'll do one more with you. Let's do B, and then we're going to talk about D, because there's something fancy with D. So if we look at B, and we did FOIL, the first terms would be x, or y and y, become y squared. The outside terms, it's like the outside of the sandwich would be y and 2 would be plus 2y. The I term in FOIL stands for inside of the sandwich. Negative 7 times y is negative 7y. And the L in FOIL stands for your last term of each binomial, which would be negative 7, 2, which is negative 14. You should end up with like terms somewhere. You have 2y minus 7y. Those combine to become negative 5y. Everything else stays the same. Y squared, negative 5y minus 14. Made that a little messy. I'm sorry. Those are y's. All right, the last one I want to talk about before I give you a whole bunch of time to practice is D. Because D is something that we would definitely make a mistake on a test or a quiz. And it's definitely something you're going to see. The reason people make a mistake on this is we just learned something in the last unit. And what we learned was an exponent on the outside of the brackets comes inside of the brackets. Right? Like that's what we learned last year. That does not work anymore. The reason that doesn't work is it only works for monomials inside the brackets. This is a binomial inside the brackets. So this trick is a no-no. And only if you have a monomial can you do that. Once you have something that's other than a monomial, so in this case it's a binomial square, what we do is we remember what it means to square something. Right? So if I told you you had x squared, that means you have x times x, right? If I told you you have 2 squared, that means 2 times 2. So if I have a binomial squared, what it means I have is a binomial times the exact same binomial. So I'm actually going to scratch out the squared and write it that way. Binomial times a binomial. And then I'm going to use whatever method I want to multiply those two things together. I'm going to use distribution. So 6a multiplies to 6a becomes 6a squared. 6a multiplies to 5b becomes negative 30ab. 5b multiplies to 6a becomes negative 30ab again. And then negative 5b times negative 5b becomes plus 25b squared. Remember, negatives times each other make positives. Again, you do have like terms. They're right in the middle. Right? You have negative 30ab minus another 30ab. That means I have negative 60ab's. The other things stay the same because they have different exponents on their letters. The big thing I want you to understand with that question is to not bring the squared into the brackets. Right? Don't do that. That only works for monomials. Otherwise, scratch out the exponent, write the extra one. Fantastic.